Good morning, mathematicians. Starting earlier today. What are we doing? We're doing spectral sequences. That is what we're doing. Yeah. Part 11. Into the double digits. I guess we were yesterday, technically.
Starting
But
earlier today.
is 0 really a double digit?
What are we doing?
I don't know. I do want to keep going with these spectral sequence calculations. I don't want to take a break quite yet, because we're sort of in the middle of stuff. So, but I think we'll do a normal office hour soon. Maybe talk about Machizuki or whatever, the triality paper. Okay. So, where were we here? Right. How dare I interrupt you with a stream when you're just in the middle of catching up with yesterday's stream? Yeah. Well, there was a lot of yapping yesterday, Arad. So, the point is, we're now looking at the path space, loop space thing. Have I read Karl Marx? Well, I think I mentioned yesterday at the end of stream. I tried reading Das Kapital when I was like 20. I got bored. I made it through a chunk of part 1, but yeah, so actually, I was going to say, but you're here for the yapping. Fair enough. Hello, Matthias. You also got interrupted when you're watching an algebraic geometry playlist. Well, I am very sorry to interrupt that. I guess for dimension reasons, actually, all of these will be 0 over here, right? All of these will be 0. So we're good on that. Now we've just got this thing here. And let's see. If S is 0, it should just be returning HT at all of those things, right? I guess we don't know what that is yet, though. Okay. And, well, we know that everything is zeros. Right, we know that everything is zeros on the final page. So, what could we say? Could I help you prove that there are infinite monic irreducible polynomials in a polynomial ring Kx? You want to hear how I did it? Infinite monic irreducibles of a certain degree, or what do you? How do you mean? Because if the ring is infinite, you just take all of these polynomials. This is monic and irreducible. Cartan B theorem? I'm not sure what that is. To start with abstract algebra, do you need linear algebra and calculus? No. Although it's maybe helpful to have seen linear algebra before. Yeah, for, I guess K is a field here. K is a field. So what? The only other thing to check is finite fields. So one just needs to prove, just in general. Well, okay, so for infinite fields, it's trivial. Just take the linear polynomials. So now the only other case you need is finite fields. So we just need to prove that there is infinitely many uh, monic irreducible polynomials. Finite fields. How does that go? How does that proof go? Um, yeah, I don't remember. I think that there's even constructive approaches to building such polynomials. Um, well, we know how do we do it? I mean, to get the extension of FP, um, one, we normally consider the splitting field of this polynomial, right? Um, yeah, which obviously is reducible. So should it just be this thing minus? Yeah. Yeah, it's this. We consider like the Galois field of order p to the n, I believe, is the splitting field of this. So I guess how do you prove this? I guess that technically you need to build up a little bit of theory of splitting fields, and then probably use the fact that that these fields can be written. What's the name? There's some like it's like the I don't remember the name of this theorem but that you can write this field as being generated by a single element, and then you can use that to argue that there has to be an irreducible polynomial. Maybe non-constructive, but I think there's a constructive approach that one can take. I can't think of what it is right now. Um, so yeah, primitive element theorem. Yes, thank you. That's what it's called. Okay, let's see how much of this we can do without looking at the steps that they take. Okay, so we know that, for example, on the E infinity page, all of these are 0. And, well, hang on. There was this one step that we looked at before. What was it saying? No, let's just do a lot of work on our own. I'm going to erase a bunch of this stuff. Oh, well, maybe we do. Maybe I should hang on to that fact. I'm remembering now they were saying that all the differentials beyond E3 are 0. So maybe we might hang on to that fact. What else can we do here? So we know, for example, okay. So all the differentials are 0. And so what does that mean? Well, the differential is bigger than that. So that means that, say, E5, which is basically E infinity, right? That's the kernel of a D4 map modulo the image of a D4 map. So it's all just the kernels of whatever D4 map, which is just 0. Wait, so it says that everything's 0 on that page? Yes. Right, but we knew that. Okay. I'm going in circles here. Okay. Your homological algebra is close to 0, so you'll just put me on as background noise. All right, then. The first and second columns are also going to be zeros because you know the cohomology of S3 is 0 in those dimensions. Oh, that's true. Right. Thank you. So, first and second. First and second. So these will be zeros. Okay. And let's see. Good evening, Ken. Definitely looks like evening even over here, even though it's morning. Okay. Nice. And now we can probably say some other things. Let's see. When is this Z going to get hit by something on this axis? From the E3 page, right? So when is the target going to be? Well, wait a second. No, we're on the E2. I'm just thinking on the E2 page. So this is 3, 0. And let's see, where does that come from? That comes from E1. Oh, what am I doing? E1, 1? Right? Plus 2, minus 2, plus 1. Right. But E1, 1 is 0. So what? I don't know. Okay. Well, let's see. What page do we need to be on to have this hit by something? We need to be on, so it's ER30, so this should be ER P plus R Q Q minus R plus 1. But also, I want the thing that we're hitting this, I want this to come from the 0th column. So I want Q to be 0. No, I want P to be 0. And so this means that R has to be 3. R has to be 3. And that means that, so 0 is Q minus 3 plus 1. So that means that plus 3 minus 2, Q is 2. Is that right? So minus 3 plus 1, yes. So this is my D3 map. The differential on the ER page always goes R spots horizontally and R minus 1 vertically. Might be easier to remember geometrically that way. Right. So what's happening when we look down at this Z then? Probably we're going to try and come up with some way to argue that this has to be an isomorphism or something. So we have this map. We have this map D3. And this is a map into Z. Maybe I shouldn't have erased my coordinates. I want my coordinates there. So this is, no, I don't know. Crap. I mean, the point is, wait. So this Z, this should be, So this will be E3, 0. And I guess this should still be Z, right? Because E3, 3, 0 is the kernel of D2 from E2, 5 minus 2 plus 1. So yeah, it's the kernel of a 0 map. Wait. Wait. No, 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 no. It's the kernel of E230 to E5 minus 1. So the top is going to be everything, because this thing is 0, modulo the image of D2 E1 plus 2 minus 1, E1, 1. Yeah, but that's also 0. So E3, 0 is just Z. Okay, great. Nice. That's what I wanted. And now E3, 0 is just Z. So I would like D3 to be an isomorphism. Well, how could I show that? Well, I know, for example, because I know that I know that the higher differentials are 0. I need to argue that this is an isomorphism. From 0 to, that's where I want it. So I've got this map from 0, 2 down to here. I'm going to try and argue that this is an isomorphism. Well, why should it be? I guess I could also argue in a similar fashion that this has to be non-zero. Why would this have to be non-zero? Well, hang on. So this converges to right. Wait. Why would this have to be non-zero? Well, I know. Okay, so maybe when I take the next map. So E4, 0, 2. I could think about what I know about E4, 0, 2. It's going to be the kernel of this thing. Modulo the image of E. So here we'll have a negative. So it'll just be straight up the kernel of this thing. And what do I know now? I know that the differential from this has to be trivial. I don't know. Okay, I'm going to look at the document. I mean, what did we do last time? Actually, I'm going to go back. I'm going to look at the previous one. How did we argue this? Okay, we argued about the existence of systems Z's. To rule out the latter being non-zero. Yeah, the intuition is there. I agree. The technicality is building. Okay, but I'm gonna instead of looking at the answer for this one, I'm just gonna go back to the previous example and see if I can, because it should be. I mean, the idea should be isomorphic, but um, right. D3 going out of here will be 0. In addition, we know that the 0, 1 does not survive. Okay, so there's something about us knowing that something will not survive. I mean, nothing survives to the E infinity page. Right. Okay, that's a crucial thing here. And yes. Okay, for R bigger than 4, since it's 0, the only opportunity to kill it is at the E3 page for us. No, it could, right. So it could either be, for us, the differential's at 4 or more. So it could be killed at E2 or E3. But we know that, but what about this E3 differential? Okay, so it could be killed at E2 or it could be killed at E3. So if we can try and maybe rule out why it won't get killed at E3, well, E3, so right. So that's at E330. Well, E330 is what? E330 is the kernel of E0. No, it's sorry. It's the kernel of E230, E5. Okay, so it's something that's dead. Yes. So wait, am I convincing myself that E330 is 0? That shouldn't be true. I convinced myself that it was Z. I already did this computation up here. Right. Oh, yeah, it's the kernel of that. So that's everything. Oh, I need to look at the image to see if the image could kill it. Right. I should finish writing out the image down here. So the image, right, and E11 is 0, so that can't possibly kill it. So it couldn't die at E3. So it has to die at E2. That's why it's an isomorphism. Or at least I think that gives us injectivity. But we know that it has to die at the E2 page. Nice. We know that it has to die at the E2 page. So that should just give us injectivity at this step. Is that right? Right, because that means trivial kernel. Okay, so what we know now is that this is injective. Why at the E2 page? Well, because it's not going to die at the E3 page, and we know that it has to die somewhere, and it can't die at the E3 page because right, because but I guess yes, because we know that the kernel is non-trivial, but the image on the E3 page is trivial. So there's no way that it can die there. And it has to die, and it can't die at E4 or above. So it has to die at E2. And so it has to be, and so this map has to be injective. The kernel has to be trivial. And now, I guess the way that we argue surge activity is, so here we're focusing on E230 being the domain. I think we make a similar argument here on focusing on this being the domain. So let's see what they did in the previous example. We also claim that it's surjective if not E320 would be non-zero and survive to E infinity. Okay, how do we make that similar argument here? You think we mean different things by at the E3 page? You mean that the D3 differentials are the ones killing it? After all, it's still non-zero there in E3, so saying it dies in E2 sounds odd. I see what you mean. Right. Yeah, so sorry. It dies at it dies at E3, but it's like yeah. But I think I'm on the right track. I think we're in agreement about how this should play out. Yeah, but I think you're right. My terminology was a little off. Okay. Let's try and argue this last part ourselves, going off the previous example. So there they say something about E320 being problematic if it was non-zero. So right, so why would that be? Why would that be an issue here? Suppose or did we just argue the surjective part? Hang on. We know that because this is zero, we're trying to argue that this map. What are we trying to argue? Wait a second. I convinced myself it was true, and I had it for a second, but right. If E3 were Z, I guess that's the thing. If 3 were Z, no, now I'm confused. Okay, I thought I had it for a second. Right. So if E3 were Z, I want to say that that's not possible. Because I guess, okay, if E3 was Z, then there would be no chance to kill it afterwards with the higher differentials. Is this true? Yes, I think that's what I was arguing here. Right. So I guess what I want to say is that E3 should be 0, but that can't be the case if E2 oh my god. I totally lost it. Okay. I nearly have it. So D2 goes between these two things. D2, I'm trying to argue that D2 should be an isomorphism. But I had it. I know. Somehow my I have very low RAM right now, and so I forgot. I forgot how I began this whole thing. I need to reconvince myself. Uh, maybe okay. Maybe I should just read the book because I did basically have it, and then somehow I like forgot the first 10 minutes of this live stream. Um, yeah. Okay. Let's just go look at it. Right. Okay. So we need to kill the z at 3,0. The only way to do this is for this to be surjective. And in fact, it must is for d3 to be surjective. In fact, it must also be injective. Otherwise, some non-zero group would survive to e infinity at 0, 2. But this would contradict this being trivial. Okay. Okay, let's go back and think about. Even reading it, I'm reconfused again. Right. We need to kill the z at 3,0. We need to kill the z at 3,0. The only way to do this is for that map to be surjective. So definitely it needs to die. Definitely needs to die by d3. Because of our argument about d4 and higher. Why is the only way to do it for that to be surjective? Why couldn't the z die? Okay, I think I already explained this. I'm sorry, gang, but oh yeah, because I mean, wait, but I thought I wanted to argue that d2 was isomorphism. I thought I wanted to argue that d2 was an isomorphism. The only way to do this is for this to be surjective. D2 could never be an isomorphism. The domain is 0. How do we know? Wait, we don't even know the domain, do we? I thought I had argued that the domain was z. Oh, maybe I got confused between the E3 and E0 pages. Right. Oh, yes. Okay, I messed up drawing these arrows with respect to the 2 and 3 pages. Okay, right. Okay, so D2, you're right. D2 can never be an isomorphism. So, right. D2 can never be an isomorphism. Right. So D. Right. So our only chance. Right. Right. So our only chance to kill it is at D3. Our only chance to kill it is at D3. And so we need E4 to be 0. Right? We need E4 to be 0. And definitely this thing will be 0. And so modulo the image of E What? Minus 3? Ugh. So doesn't that mean we need E3 to be 0? That means we need E3 to be 0. No. What? I'm so confused. We need to kill the Z. Why would E330 be 0? Well, wait, E330? Oh, sorry. Yeah, we're looking at E330. What am I writing? I wrote the wrong thing here. Okay, sorry. We need E4 to be 0. So we need E430 to be 0, which is the kernel of E330 to E0, E0, 0 minus 4 minus 1. Well, this is 0. This is 0 again. So it's the kernel of this, which is just everything, modulo the image of E0 plus, so 2? Nice. Okay. And that's what we wanted. Any rule of thumb on learning math faster than an average person? Yeah, be above average intelligence. I mean, the thing is, why do you want to learn math faster than the average person? Like, by definition, you should expect yourself to be at the average pace. Math is not intuitive for you as a rigorous manner. It's not intuitive for like humans in general. We developed, we evolved to try to not get eaten by saber-toothed tigers. We didn't evolve to make rigorous proofs about the convergence of a spectral sequence. So I mean, what's the rush? I mean, almost everyone, so far, the vast majority of people who have ever been born have been died. So, it seems likely that, you may die. And so, okay, maybe the rush, you say, is that you want to learn something deep and meaningful before you, the presumably finite amount of time you have on this planet. But okay, so you want to accelerate your learning, but faster than the average person? I don't know. Do I not have a rule of thumb? I should have. Why should I have such a thing? This doesn't make sense to me. Never in my career have I strived to be a matter of personal time. Yeah, I mean, I guess that's something, but then it's still a weird way to phrase it, right? It's like a matter of personal time. Okay, maybe you have limited hours in the day, but then why phrase it as faster than the average person? Like, why compete with the average person? I don't know. Like, I don't yeah. Just learn math. I don't know, that you found interesting. Hey, actually, can't you follow Euclid's method for proving that there are infinitely many primes? Oh, yeah, maybe. Plus, use the theorem that a polynomial in Kx with degree bigger than 0 is irreducible or a product of irreducibles. Maybe. Yeah, I didn't think about that. But that's maybe not a bad idea. Yeah, assume that there are finitely many. Assume that there are finitely many irreducibles. Multiply them all together and add one and obtain a contradiction. Yeah, that's nice. That's a nice idea. It is going good. I'm running myself in circles. But now I think I finally get it here. I finally see here. I finally see here what's going on. The top part here is all of E3, so the bottom part. So we know that D3, the only way for this to be true is that D3 has to be surjective. So this we know. This we know. Yes, rules of inference are different than axioms. Axioms are like the starting state or like the initial state, and then the rules of inference are the, laws by which the system evolves. What I said reminds me of a funny quote. Scientists and philosophers used to argue that what separates humans from other animals is our ability to create tools. This is clearly false. Macaques in Thailand have been recorded using hair as floss. Octopi often use coconut shells as battle armor. That's badass. That's badass, really. They use coconut shells as fucking metal. No, what separates humans from our animals is to create spectral sequences. To date, no other species on Earth has been observed using spectral sequences. That we know of. Yeah, that has been observed. Who knows what's happening in the dark, though? Those, dolphins are pretty smart. What's the next sequence after spectral? Will I finally live up to my YouTube username? Maybe. I thought about it. I've been thinking about making videos on it, but maybe just live streaming through K-Theory. You think it's crazy how fast the difficulty is increasing? You're 2 months in and you've learned more than many years in high school. Yeah. What are tips of following a lecture in maths, like what the lecturer is doing? I'm not sure I understand. Octopi do not have a central brain. They have more a decentralized neural structure. Also badass. Clearly the eels go to the deep to work on spectral sequences. Yes, well, of course it's a joint effort with all sorts of sea life. And of course the eels are there to be the morphisms. And the alpha eels are the ones that get to be the connecting homomorphisms, of course. Okay, great. I'm happy with the fact that this map has to be surjective on the E3 page. Why does it have to be injective? In fact, it must also be injective, otherwise some non-zero group would survive at 0, 2. Is that so? Is that so? Well, it has to be surjective. Otherwise, why? If it wasn't, why? What the professor is doing probably in a lecture, if that makes more sense to you. No, it doesn't really make sense to me. Some humans don't have a centralized brain either. About 80% of my brain is Instagram reels. Well, I mean, that's true. Very few humans have a centralized brain anymore. I mean, right? I mean, ever since the invention of writing things down, even before computers, the invention of writing things down to remember them. I mean, you're outsourcing like computing power, memory power. Um, so yeah, I do think about things like our phones and our laptops, but even something as simple as a notebook of really as really an extension of the self. Um, if I write an equation down in the notebook to remember it for me later, then I'm not storing that in my brain. That's external storage for my brain. So that's now part of the network of my brain. Um, yeah. Okay. But let's understand this comment about injectivity. E3, E3, like what he's writing on the board, the proofs he's doing. What tips do I have of following? I don't know. I mean, I'm not sure what to say. To stay focused in 2 hours can be exhausting. I don't know. Drink coffee. I mean, I find a 2 hour lecture. To be fair, that's too long. I mean, I have no attention span anymore. Like whenever I go to a talk or something or a lecture, I'm always doing my own work. I'm not really paying attention all that closely. So to be honest, I do most of my learning at home. Maybe the better way to do it is read ahead. Um, yeah, I don't know, and then take notes in lecture and then study them at home later. I mean, I always learn better on my own doing the exercises than I do in lecture. I think lectures are better for asking questions. You would call tech an externalization of reason or thought in material form. This can be really different between people. For you, it's useful to write down notes. Yeah. I mean, that's something I do. I find I don't retain a lot necessarily, but my live teching skills are good, so I at least like tech notes, and then that just keeps me busy during lecture, and then again I do my thinking before and after. Gotta go work. Cryptography time. Hell yeah. Hell yeah. According to a quick Google search, 2.5 gigabytes is our brain capacity. That's more than enough. That knowing to perfection all the EGAs. Or 2.5 million? 2.5 M? I don't know. Yeah, but the thing is, you can't just know EGAs. You got to know how to, like, wipe your butt and stuff. You need a lot of non-math knowledge to do math, even. You got to know how to, like, write with a pen and stuff. So that takes up a lot of space if you think about it. Otherwise, some non-zero group would survive to infinity. Why? 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 The kernel is surjective. How could we argue this though? I mean, we already looked at E4 and deduced things from that. Surjective. Oh, I guess maybe we should look at something. Right. I guess we should look at something based at 0, 2. This other thing wasn't based at 0, 2. Right. So if we look, now we turn to E4. Now we turn to E402, which would be the kernel of E302 to E to E303 modulo the image. Right, and now this is going to have a negative index, so this thing is 0, and so we need this thing to not survive, so the kernel must be trivial. Okay, so finally, it took all damn stream to convince myself of something I already convinced myself of at the beginning of stream, and then somehow I forgot, speaking of external processing power. Perhaps I should write down E4 in full. It'll have cur D all along the entire 0th column, and co-cur D along the 3rd column. But E4 is E infinity, so those are all 0. We'll have kernel D along the entire 0th column. And co-cur D along the 3rd column. Right. You're saying these will all be kernels of the respective maps, and these will all be co-kernels here. I see. Right. So, so all the E3 kernels are 0. Or sorry, all the D3 kernels here are 0. And all the D3 co-kernels are 0. Is this correct? I think that's correct. Right. So, okay. Great. But why do we have... Wait, so part of the takeaway of that was supposed to be that there's a Z... Part of the takeaway should have been that there's a Z at 2, 0, right? Part of the takeaway should have been that there's a Z at 2, 0. But why? Well, maybe this is the part I was saying earlier, because we know that this should... I mean, this survives one step. Right. This should survive a step. And then we have something else surviving a step. And it needs to kill that Z. Something like that. Next we can fill in a Z at 3, 2. Why can we fill it in at 3, 2? Why can we fill it in at 3, 2? Why can we fill in a Z at 3, 2? And presumably we're putting zeros in everywhere else. Okay, well, we know we've got zeros everywhere here. I guess I see. So I guess this I could fill in with a 0. This I could fill in with a 0, because if I imagine going to the higher pages and turning the lines that go down here Like, it's all just going to be hitting zeros. So the only way that could ever die is if it were zero to begin with. I don't know about this question mark yet, but I guess maybe the idea is once we know that this is z, this could only be maybe hit by the z at some stage, but then beyond that, no, I'm just cooked. I'm cooked. Chat, I am cooked. Okay, I understood at least a non-zero amount of stuff today. Repeating the previous sequence of deductions upwards indefinitely, we find that the E3 page has z at 0y and 3y for every even coordinate. There's no space for differentials since H star of S3 forces a gap of size 2 between the interesting columns. These groups must also live on E2 in the same positions. Okay, there's a lot going on in that sentence. I feel like it would help me to rewrite this whole proof, but with more detail. For myself personally, that's what I need. Lots of slow, gruesome detail. But I'm willing to accept it for now. In particular, the cohomology of this consists of 0 in every even dimension as seen on the vertical axis. Let ABC be the generators for these. Then we get generators as such by a similar grading count thing. Inspired by the preceding example, we can use the Leibniz rule to relate some of these differentials. That's all fine. This describes a divided power ring. Oh. Yeah, you did the same calculation once as an exercise, and your proof was disgustingly detailed. Yeah, I feel like that's what I need. Divided power ring. What is that again? Commutative ring with an ideal divided power structure on I. Okay, let's read the short sentence. Divided power structure is a way of introducing items with similar properties as those have. Also, when it is not possible to actually divide by that. Okay, well, this is good enough for now. That's good enough for me. So let's leave it there. I wonder, yeah, maybe I should go back and just write this up and internalize it on my own, and you should all do the same, unless you're a rod and you've already done it. Maybe tomorrow we jump over to SUN. Scroll through that. More examples, the better, right? I don't know. Or, I mean, we're at a stopping point, so we could have a break and have some normal office hours. Who knows? We'll see. I'll make up my mind tomorrow. You never know. Where am I going to go? Okay.